Hi, this is Amy Lewis. This is Engineers Unplugged. Hi, this is Amy Lewis, and you're back with another episode of Engineers Unplugged. We've got J Metz, and we've got Francois, and we're going to be talking about flash acceleration. So, Jay, what's going on here? Take it away.
Thank you very much, Amy. So how you doing, everybody? Yes, my name is J Metz. I'm a senior product manager for storage at Cisco and work very closely with Hitachi on a number of different projects and certified validated designs, which we're going to be talking a little bit about. But here at VMworld, there's an awful lot of sessions and storage conversations that have been going on, and a lot of it has to do with the kinds of things you can do with flash storage that you weren't able to do before, including things like breaking down silos and being able to be much more flexible in how you scale out your data center. So Francois, you have some ideas about how flash acceleration should be well understood to be able to accomplish this, yeah?
Yeah. So what I want to drill into is, so flash is pretty hot at the moment. We know that adoption rates are more than 100% compound annual growth rate per year. And what I really want to drill into is this fact that a lot of vendors out there are creating multiple infrastructure silos where what you see is weird definitions like hybrid arrays versus flash-only arrays versus all different flavors of arrays. And I really don't think it makes sense from an infrastructure perspective to have multiple silos just because you're trying to implement a new type of media. So what we think, and this is something that we've kind of learned through development with Cisco, we were putting together a converged platform. Our goal was, how do I build one platform for all applications? So how do I have a unified platform which can give me all flash performance, as well as hybrid performance, as well as that slow stuff for all the data at rest. So really what you see is when you look at the market, there's kind of two places you can install flash. You either put it up here.
Uh-oh, catastrophe.
There we go, catastrophe. Whiteboard session with no marker. So either you put it up here.
I blame Amy.
In PCI attach it right into the server there.
Yep.
Or you put it down there into the storage, and that's it. Those are your two choices.
Okay.
But what we've seen is because people have processing limitations in their storage, they've come up with all sorts of weird concepts like hybrid arrays versus all flash arrays. And when you look at this from an infrastructure management perspective, if I have multiple silos and I'm trying to run a converged infrastructure, I suddenly have a massive problem when I'm trying to provide storage as a service. So what we were looking at is how do I get rid of these silos? So what we need to do is we need to offer our customers something which doesn't make them choose between functionality here, so quality of service, performance management, dynamic tiering, all of those things you get out of hybrid arrays, and sub-millisecond response time there. And that's not an easy task. So the reason that this is difficult is because these all flash arrays have lots of processing. They have processing because flash is a difficult problem. You need to be able to do garbage collection, zero block compression, endurance management, all of those things. And what they've said is, my current array is not good enough for that. So when we looked at this problem, we took a different approach. We said, why not embed processing on the flash modules? Whenever I install a flash module, install processing. So build a system on a chip, drop all of this stuff into that instead of into a dedicated all flash array, then get rid of these divides. And whenever I install flash into the back of an existing storage array, I scale out processing linearly. So the functionality improves as you add additional capacity. And we think that's a model going forward. We think this idea of being able to embed the functions in a scale-out compute architecture that you attach to the back of a storage array makes a lot of sense.
So one of the biggest reasons why we have these kinds of silos has been, one of the reasons has been because we've been looking at doing some tiering kind of things and being able to have applications that have specific requirements go into a particular silo and be able to provision that. Yeah. So if I understand what you're saying correctly, what's happening is now we're being able to compress, pardon the pun, all of that hardware functionality down into the actual flash arrays and then allow the tiering to be done through software at an upper level.
No, so really what I'm looking at is, so really what I'm looking at is if I take an existing enterprise array and instead of throwing out the microcode and starting again, for flash functionality, I embed that right into the actual flash card. I drop in a bunch of ARM chips, I drop in a system on a chip there that will do that. Then I can reuse all that existing array functionality, and what I can do is inside a storage array, I can spin up a virtual partition that is an all-flash array, I can spin up a virtual partition that is a hybrid array with other slower disk resources, and I can spin up a virtual partition which is a slow and data at rest type thing. And that is the way to move to a cloud delivery model that includes flash. So the whole thing here is this gets a whole heap of processing, because when I install the flash, I add processing, so I add performance. This gets the processing it needs because it's got a layer of flash over. Even if we want to do virtualized third-party storage, we can apply a layer of flash over the virtualized stuff. And then this stuff is, bread and butter. Okay. So that's kind of the model going forward. We think it's got a lot of legs. We have evidence for, if we look at things like NFS benchmarks, so SpecFS, you can see 64 of these flash modules can outperform 525 regular old SSDs from our nearest competitor. So it's an order of magnitude improvement.
So break those numbers down into a visual here. So how many racks and how many rows are we talking about there for that?
So we're looking at 8U versus 3 racks.
Yeah, I think that probably qualifies as a decent compression of physical space, that is.
Yeah.
And thanks for clarifying that, because I wasn't really sure if this was going to be an evolutionary process, which it sounds like it is, or if we were going to have to do that rip and replace.
Well, yeah, and so this is the idea. So we have customers that have deployed our systems in 2011. We launched this year. They've taken those systems that are general purpose systems, 5 millisecond response times, got less than a millisecond response time out of them just by retrofitting into an existing system. So good investment protection. And the most important thing is when you look at how the business is going to use it. So when the business wants to adopt flash, what they'll do is they'll first go after tier 1 apps. So they'll drop in some accelerated flash, and then they'll virtualize the legacy storage for that tier 1 app. And then they'll decide, either I'll move it to all flash if that's what it needs, or I'll just accelerate it. Then they'll go after the rest, they'll consolidate that, and then finally they'll use flash as part of their cloud storage delivery offering. So that's the way we move to automated programmable storage.
Sounds good. Well, unfortunately we're out of time, so Amy's going to come back here and yell at us.
Oh, I think they picked up one of my great discussion, really interesting, I appreciate that. But of course there's one more thing. So we talk about data at rest. I'm really interested in unicorns at rest. So it's unicorn time. Unicorn at rest. Let's go. 10 seconds. Yeah. Fast unicorn at rest. Let's go. Wait, is that unicorn at rest? I sometimes I'm at a loss for words. It's rare, but I love it. It's a forward-looking thing, much like flash acceleration. So thank you, Francois. Thank you, Jay. We'll see you next time on Engineers Unplugged.